You don't have to write anything on this first part. I just need you to listen and kind of read through it with me. A conditional statement is a logical statement that has a hypothesis, which we usually call P, and a conclusion, Q. Oftentimes we write this in if-then form, which is what I made you do yesterday. If the hypothesis, then the conclusion. So if P, then Q. This is a picture book that you might recognize. If you give a mouse a cookie, then he will want a glass of milk. Do you recognize that book?
Heck yes.
Okay, we'll talk about that book tomorrow. Negation, you guys negated yesterday. A negation is just the negative of the statement. Oftentimes we use not, but not always, because if it already says, like, Serena Williams did not win, then you would, to negate that, you would say Serena Williams did win. So the negation is just the opposite, just like the opposite of negative is positive. So sometimes you'll see that symbol actually in the book, and I realized this today. The book uses this squiggly line, which I'm kind of mad about, but that's okay. That's what you'll see the book use for negation, saying not P or not Q. So some examples. The cat is blue. The negation of that is the cat is not blue. Don't use the words isn't or doesn't. If you're trying to negate, it is dark. You do not say, it is not dark. You say, it is light. So you're doing the opposite. If you get confused, some things you can do. Figure out the hypothesis, P. Figure out the conclusion, Q. And then put them together in if-then. If hypothesis, then conclusion. So looking at the refrigerator will remind him he is thirsty. This is from that book, The Mouse. Looking at the refrigerator will remind him that he is thirsty. Jacob, what's my hypothesis?
If he looks at the refrigerator.
Okay, so he is looking at the refrigerator. I'm going to write fridge. And what is the conclusion, Sarah? He is looking at the fridge. What's the conclusion? Okay? So my if-then statement, put that together as an if-then statement. Lucas, what's my if-then statement going to be?
If he is looking at the fridge, then he is thirsty.
Good.
Or if he...
And that's what I would have said too, Shayla, and I think that's what everyone in this room would have said, but Mrs. Brandt is happy is the conclusion because that is the effect, right? So you got to think about that is what happens. What is the cause here? What's the cause, Garen?
If her student, when her students bring her Sarah.
So that's causing me to be happy. And so your hypothesis is actually the second part. When students bring her Sour Patch Kids, and then the conclusion is she is happy. So it's not always in the order that you see it. So hypothesis, students bring, I'm going to put SPK, Sour Patch Kids. That is my favorite candy. I will be happy with you if you bring it for me.
I'm going to bring it all on there.
Students bring Sour Patch Kids. Zach, what's my conclusion?
That Miss brings that.
Good. So our if-then statement. Sam, what's my if-then statement going to be?
If students bring her Sour Patch Kids, then Miss Brandt will be happy.
Great.
What did you say?
If students bring
Just bring it.
Sour Patch Kids, I'm abbreviating, then Miss Brandt will be happy. Or then Mrs. Brandt is happy.
Doesn't matter if he says students or Miss Brandt's students.
Just use students.
No, it doesn't matter. It means the same thing. A combined statement containing both the if-then and the converse. That should say contains. Contains the phrase if and only if, or sometimes you'll see me write it as an if with two F's, so if. It can be read forwards or backwards, and all definitions that you see in math and in this class are biconditionals. So any definition that you see can be written as a biconditional. So let's read this statement. Perpendicular lines are two lines that intersect to form right angles.
They form two right angles, then they're perpendicular lines.
I would say let's go ahead and keep it in the order that it's in. I see so both of these statements are going to be true. And so I would say that's probably the converse. So the inverse, Olivia, would be what?
If they are perpendicular lines, they are two lines that intersect to form right angles.
Yeah. So let's use that for our if then. If they are perpendicular lines, then they intersect to form right angles. And you're going to see me use a symbol for perpendicular. Looks like this. Pretty much from here on out, that's what you're going to see, because perpendicular is kind of a long word, and I'd rather not write it out every single time. So we do using a lot of symbols, a lot in geometry, because we do a lot of writing, and you'll see that today. So it's easier to just use the symbol for perpendicular. Okay, converse of that. Sam, what would you have for the converse again?
If they form right angles, then they're perpendicular lines.
Good. Oh man, I should have written smaller. We'll say if the lines form right angles, then they are perpendicular. So remember, this symbol means perpendicular. I don't want to write it out. Don't need to write it out. You need to look at the if-then statement and the converse and decide, are both of these true?
Yes.
If they are perpendicular lines, they form right angles. Yep. If lines form right angles, they are perpendicular. Yes. So they're both true, so we can write a biconditional. My biconditional would say we're going to get rid of the if and the then. We're going to replace it. So two lines, I'm going to write it in the summary because I'm out of room. Two lines are perpendicular, using the symbol. If and only if they intersect to form right angles. You will sometimes see, so this is the biconditional. The converse is in red, and the if-then is in black. Sometimes instead of seeing if and only if, you're going to see it written as IFF, again, to shorten out what to say, because we don't want to write it out every single time. And lastly, so we filled out the chart in class. Remember that our four terms are if-then, converse, which is if you flip it, inverse, which is when you negate the original if-then, and contrapositive, which is when you negate and flip or reverse. We can decide if they're true or false, and if it's false, we give a counter example. And we use Q and P. Remember, P is the hypothesis, Q is the conclusion. So if we're flipping it, then it would be Q to P. This little sign right here means not P. So copy that down, but we went over it in class, and I don't have time to go over the entire thing again.